Today's show is sponsored by Datadog, a real-time monitoring platform that unifies metrics, logs, and distributed request traces from your cloud containers and orchestration software. Track the health and performance of your dynamic containers, apps, and services with rich visualizations and machine learning-driven alerts. Datadog's cluster agent streamlines data collection from large container clusters and allows you to auto-scale Kubernetes workloads based on any metric you're already collecting with Datadog. To start monitoring your container clusters today, sign up for a free trial, and Datadog will send you a free t-shirt. Visit datadog.com/cloudcast to get started today. That's datadog.com/cloudcast.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We are coming to you live from the massive Cloudcast studios as we move into the middle part of July 2021. Hope everybody's doing well, and especially hope my 14-year-old nephew Johnny is doing well. Apparently, my brother has started making him listen to the Cloudcast podcast on some of their long drives, commutes, and summer vacations and so forth. And apologize for that, Johnny. Sorry, my brother's making you do that. But apparently, my nephew thinks I have a lot of energy in my my introduction. So appreciate the comments, appreciate the feedback, and let's jump right into Cloud News of the Week because there's a lot of money that moved hands, a lot of money changing hands here, not only in this week, but also in sort of the first and second quarter of the year. So let's jump right into that. Some numbers came out for VC funding in both Q2 and Q1, and Q2 apparently was a record number kind of ever. So $156 billion in VC activity in Q2 for 2021. So what is that, April, May, and June? Lots of money changing hands. And $288 billion so far this year. So lots of bigger deals being thrown around out there, lots of money investing in innovation. So obviously I think people, where the money, we always say follow the money. So obviously the money is running towards innovation. Hopefully we're going to start seeing some really, really interesting innovation. And I think, that sort of makes sense because we talked about, Aaron and I have talked about this maybe on the end of the year 2020 show or some of the others. Anytime we have a huge issue, global issue, whether it's when the market crashed in 2001, the dot-com crashed, or we had the financial crisis in 2008, and then obviously we had the pandemic last year. Usually you see some pretty interesting and sometimes dumb, but pretty interesting innovation come out of that. And obviously nowadays, with innovation happening so fast, I think we're seeing more and more money being thrown at that innovation to try and make it accelerate even faster. So lots of money floating around, and let's dive in a little bit into some of where that money's floating around. Microsoft decided to acquire digital threat management firm Risk IQ for $500 million. So Microsoft making another big investment in the security space. Obviously, people doubling down on security, software supply chains. Microsoft has been really kind of amping up their what we call cybersecurity, watching the internet, watching what's going on. This is going to help that. And another company with a similar name, but a different company, Attack IQ, gets $44 million in funding to advance security optimization. So lots of money flowing into the security space. Obviously, that makes sense. We've seen a lot of very high-profile ransomware attacks and software supply chain attacks here recently. So a lot of doubling down on maybe some alternative, hopefully better ways of securing all of our data, whether it's credit card data or, things that are keeping oil refineries running and everywhere in between. And then finally, we want to give a big shout out. We've got certain friends of the show that we always like to see doing cool things. And friends of the show, both Sebastian and Mark over at TriggerMesh, got a new round of funding, both from Cisco as well as our friend Anil Lakhani, who is now in the VC space over at Crane, making an investment in TriggerMesh. So TriggerMesh, lots of focus around event-driven applications, new types of applications with event-driven streams, work around Knative. So congratulations to those folks. Good to see money flowing into some very smart folks and folks who have been have a track record of getting things done and obviously moving the ball forward in terms of new technology. So congratulations to TriggerMesh. And that kind of wraps up our Cloud News of the Week. A lot of money flowing around, like we mentioned, literally hundreds of billions of dollars so far, almost $300 billion so far in the first half of the year. We'll see where the second half of the year goes, but exciting time to be working in innovation, exciting time to be working on new technology, and also kind of an exciting time to be working on containers. And we're going to dive a little more into what's going on with containers, especially in the public cloud, right after the break. Today's show is sponsored by Spot from NetApp, the cloud automation platform that makes it easy to deliver continuously optimized infrastructure at the lowest possible cost. Spot helps customers get the most out of their cloud investments by automating cloud infrastructure to ensure performance, reduce complexity, and optimize cost. Their machine learning and automation scale to exactly meet application needs using the most efficient mix of instances and pricing models, eliminating the risks of over-provisioning and cloud waste. Best of all, their software works with leading cloud platforms, services, and tools so that you can simplify and automate your cloud infrastructure wherever your workloads and applications run and however you run them. Discover how leading companies, from cloud-native startups to global enterprises, are automating, simplifying, and optimizing their cloud infrastructure with Spot by NetApp. Check them out at spot.io/cloudcast, where you can find more information, quest a demo, or even start a free trial. That's spot.io/cloudcast.
Today's show is sponsored by Okta, the leading independent identity solution. Okta provides best-in-class authorization so your customers and workforce can safely access what they need most right when they need it from anywhere. Organizations around the world trust Okta's Identity Cloud to sign in, authorize, and manage users, whether it's employees, contractors, partners, or customers. And with Okta's developer tools, you'll never have to build authentication again. Our customizable code blocks are flexible and future-proof with easy-to-use APIs and SDKs, so you can do less coding and more shipping. Okta is dedicated to building the most reliable, neutral identity platform because it means protecting more than a login. Identity is protecting people, their ideas, their work, their brilliance. It's protecting your future with confidence. Learn more at okta.com. That's OKTA.com.
And we're back. And folks, as you know, there's a lot of topics that we cover on the show, but there are certain core topics that people really are attracted to. They want us to dig into more and more. And, as one of the things that we love to do is dig in not only, into the technology, but also kind of the data, the reality, the trends that are behind that. And obviously, containers and Kubernetes is a big part of the technology story today. It's a big part of what a lot of companies are doing. They're experimenting with containers and Kubernetes. They're beginning to deploy applications in there. We crossed over the 5 and 6 year anniversary of Kubernetes being launched. So really excited today to dig into that a little bit more, and excited to do it with our good friends from Datadog. So excited to have Michael Gerstenhaber, who is Senior Director of Product Management, focuses on this space. So Michael, great to have you on the show. Welcome.
Likewise. Thanks so much, Brian.
Yeah. So we're going to dive into this. Obviously, one of the things we love doing with you and the good folks at Datadog is we dive into the data. You guys do some surveys, periodic surveys where you look at actual usage. Before we dive into that, give us a little bit of your background, kind of how you got to the space that you're working on at Datadog, but also just some of your background, so folks have a sense of kind of the breadth of where you've been.
Yeah, absolutely. I'm a software engineer at heart. I started my career in software engineering at Cisco Systems. And back then I was working on a network management. Network management is a little bit different than what we do here at Datadog, at least for now. We don't focus on provisioning the way that a network management tool does. We do monitoring, but otherwise it was a nice primer for what I do now. I got into the business side in the startup world when I joined a company that delivers video games streaming, and then that tapered off. I joined Datadog and got back to my roots, working with dev tools, with engineers. It's interesting because you can come to product management from a lot of places, I think, but having built engineering tools, built dev tools that are used by other engineers, the audience for my products were a lot like me, and I think it just helps a lot to know where the engineer at the keyboard is coming from when you're building this particular sort of product.
Yeah, no, absolutely. It's we've always sort of aspired and enjoyed talking to folks who've sort of lived with the pain, I guess, if you will, of some of the things that their new technologies are solving. They know that they work. They've sort of proven them over time. They've lived with the pain of it. So excellent to kind of get that background. As I mentioned in the open, we're going to talk about container usage. Like we mentioned, Datadog publishes a great sort of state of containers and sort of insight into it. As you look at container usage, especially in the public cloud, obviously there's usage in on-premises and data centers, but particularly in the public cloud, just beyond kind of the rapid pace and growth, what are some of the big trends that you are seeing, that you're sort of following as you're thinking about new tools that you want to bring, but kind of what are the sort of bigger trends that you see around container usage?
Yeah, it's funny how the answer to this question has sort of evolved over the years, right? 4 years ago when we started tracking this, it's are people orchestrating their containers or just running Docker containers, and that it evolved into how are people orchestrating it? What are they hoping to gain out of orchestration? Are they using Kubernetes, ECS, Mesos, Nomad back then? And now more recently, it's whether they are realizing the fruits of their labor. Are they seeing the efficiency gains? Are they seeing availability and high throughput product? Is the safe multi-tenancy that they get out of containers really proving the value that they got into the complexity for? So we're watching different things, and recently it has been around newer technologies like service meshes. We've studied the utilization of containers compared to the limits assigned to them, whether people are optimizing by assigning limits and bin packing and that sort of thing.
No, it makes sense. And, like I mentioned, the reports that you guys put out go into really nice amounts of detail. I'm always a little bit surprised. We get newer technologies, they come out. In some cases, people talk about containers replacing VMs. And obviously, we used virtual machines as a way of bin packing, trying to be more efficient. I'm still sort of surprised as I look at some of your data, which is, pulled from real usage, just we're still not great at that, right? We have these sort of sophisticated tools, but we're still, I think psychologically, we're not completely, convinced that we need to use 100% of resources or, all the memory we've allocated. Are you surprised at sometimes how inefficient people still are, even with more modern technology?
I guess there was a time that I was surprised by that. But if you think about when you say more modern technology, we have to keep in mind how modern it is. You mentioned at the top of the hour that Kubernetes itself just crossed the 5-6 year mark, right? We're not talking about job descriptions with decades of experience here. So I think a lot of people recognized the promise in container orchestration and in containers themselves, but bringing their applications into an orchestrated ecosystem requires a migration, right? Only very recent apps were really born into containers, but otherwise people are lifting and shifting old Java apps with 30 concurrent processes into containers, and then doing the manual labor of breaking it apart into microservices and figuring out precisely how many resources these things will use 99% of the time, and understanding CPU throttling and the killer and the repercussions of all of these things. It's a lot of mechanical understanding that you have that goes into optimizing. So first, there's this serialization. First, we move into containers, and then we optimize containers. And I think while the fact in our study showed that people are generally poorly optimized, it is showing that people have moved there and they have started that optimization process, which implies increasing maturity as you would expect over a period of time.
Yeah, well, and that makes sense. It's you forget, if you live in this space a lot, you feel like it's been going on for a long time, but you're
exactly
right. It's 5 or 6 years is a blink of an eye in the bigger picture of things. I'm curious. One of the things that I've learned over the years with containers and Kubernetes is, there was sort of in the early days, people would kind of bring existing tools to the space, and they would just assume, well, this tool for logging or monitoring or whatever, security worked pretty well for VMs. This is Linux is still sort of, and then over time you realize no, there are some unique things that you have to do with the way containers work, right? Whether it's how they're ephemeral or whether it's whatever. What are some of the things that you guys at Datadog have had to do to kind of be more, I don't know, more efficient or more kind of optimized for monitoring containers? Like, are there unique things that you have to do because it's containers, or have you not seen that as much?
Well, I mean, it's actually helpful here that we made the decision a couple of years ago to move entirely into Kubernetes. So we run all of our systems at a very high scale, tens of thousands of VMs, hundreds of thousands of pods. I can't use real numbers, but very large numbers.
Yeah.
Part of the reason we do that is to understand what it means to monitor things in containers. I don't know, the word unique does a lot of heavy lifting, but
Sure.
the scale here is different than in VMs, right? Each time series is tagged by a number of construct, especially in Kubernetes, but in ECS as well. And also the containers and workloads themselves are, like you say, more ephemeral, right? They churn something like 500 times faster than the VMs, the nodes that underneath them. So there's this mechanical aspect of monitoring where you need to be able to store and query the data efficiently. And it's sort of table stakes, but it does get harder with any system, and especially when things are self-hosted. So the other thing is that there are these tags. Nobody is really interested in what an individual container is doing. Like I say, they churn pretty fast. Usually the easiest thing to move into containers first is a stateless service anyway. And you have to really reason about what matters to you and what matters to your customer. Now, there's some irony here, in as much as the atomic unit has shrunk from a VM to, even an individual process or a cluster of process that happen to be namespaced and controlled by a C group. In reality, you are monitoring the same durable objects, right? You are monitoring the quality of your services. The way those services behave is governed by Kubernetes, but it's important to remember that the goal here is to monitor what matters to your customers and to provide a high quality of service to your customers. So you're still going to want to alert yourself, wake yourself up at 3 o'clock in the morning if latency is growing, if those customers are having a bad time. And that's the same as ever. It's where you drill down and try to figure out what's going on underneath, that things have changed, that a process doesn't run on the host that you provisioned for that process in the way that you would expect. So being able to monitor a high cardinality, a large number of signals, and aggregate them into meaningful surfaces is what the challenge is really with the time series and log aggregation.
Yeah, no, that makes a ton of sense, right? Especially like you said, you're dealing with higher volumes, higher frequency change rates, and so forth. So that makes a ton of sense. One of the things that really surprised me is, as I looked at it, some of your data said, hey, we've now reached a point, this was end of last year or this part of this year, where, 50% of containers are being orchestrated by Kubernetes. Now, a high number are being orchestrated, but only around 50, a little more than 50% are by Kubernetes. What else is driving the orchestration? Is it, is it still legacy things, a Mesos or a Swarm? Is it primarily ECS? Is it some other homegrown stuff? Like, do you have a sense of what makes up that other 50%? Given how much everybody talks about Kubernetes, I was sort of surprised the number wasn't higher than that.
Yeah, Kubernetes is a very powerful tool. It's a very, I think it's become partially the de facto standard in everybody's mind because it is open, because it is portable. But ECS is enormously popular, right? It's easy to get started with ECS. Amazon is a very popular cloud provider, and their native tool is one that people will take off the shelf quite a bit of the time. It's also been the managed service, the managed control plane, the only option for that for a very long time. So unless you wanted to roll your own Kubernetes clusters on Amazon, you didn't have a choice. EKS came along, and we do see very heavy EKS adoption as well, which is another thing about monitoring containers, right? Is this split between the developer and the operational staff in a way that sort of backtracks a little bit from from what we saw in the shift to DevOps over the years. Kubernetes, ECS can be very complex platforms that require their own care. So in as much as in the DevOps world, an individual application team would provision their own infrastructure, now they're provisioning their own workloads on the infrastructure managed by another team, right? And the less that people have to take care of the boilerplate parts, the control plane, the API layer, the better. And ECS was a common, and has been and still is a common component to use for that.
Right. Well, and I think, as you laid out, right, more and more people would just sort of like things to be taken care of for them, especially if you're on the developer app side. So we're seeing things like Fargate, we're seeing things like GKE Autopilot. I mean, like we've seen, our industry has a tendency to sort of see ideas that they like and sort of adopt them into other places. So, the things that ECS has done with Fargate under the covers, I think we're seeing that with EKS, we're seeing it with Autopilot, we're seeing it in other spaces as well. So yeah, that makes a ton of sense.
And we do see Fargate exploding in usage. We integrated with Autopilot recent release, and I do think that's a very strong pattern as well.
Right. Another thing that sort of jumped out at me that I don't know if it seemed initially sort of counterintuitive, but sometimes things in containers sometimes feel counterintuitive. It was, in larger clusters, you're also, so larger clusters meaning more nodes, you're actually seeing a lot of those nodes be big nodes. And, for a long time, we talked about sort of pets and cattle, and, you'd have smaller nodes because they would, you don't have to do as much. Were you surprised that sort of volume also drove sort of largeness of nodes, or is that a correlation that sort of made sense to you?
Yeah. So with these studies, we don't always derive a causal relationship so much as this is the actual behavior, and it's hard to say for sure why something happens. But talking to customers, I think one of the things that we find is that there's this tension between the efficiency that the scheduler can use to schedule, which benefits the large node, and the blast radius of any outage. If you have a large node with tons of workload on it and it goes down, all of a sudden you have to reschedule, thousands of replicas, and you can run into trouble, capacity problems, not being able to fit those workloads somewhere. I think what we do see is that it becomes harder and harder to manage clusters of large sizes, right? 100 node cluster, 200 node cluster is, in my experience, for a large customer on the large side of the median. And when you get up to 500 node clusters, it's very large. So as you add nodes, it becomes harder to add more nodes, and you tend to vertically scale those nodes because it's a little bit easier than adding nodes. And then when you can't vertically scale them anymore, it becomes uncomfortable to do so, you start adding more. So there's sort of a zig and zag there as you optimize your clusters.
Yeah, and I guess that makes sense. I remember, in the early days of Kubernetes, there was some early work done of, can we test a 1,000 node, 2,000 node cluster, and the CNCF had done some stuff,
exactly.
Intel had done some stuff, and now we don't really hear about that much anymore. We heard about the one 15,000 node GCP thing, but like you said, I think the trend we see is more smaller clusters, just because, as you mentioned, managing them and then dealing with the life cycle of them becomes a little more challenging. So I guess, yeah, now that I think about it, that does, for when you do it, the nodes within it would make sense to be a little bit bigger. I think that sort of leads me to ask about a second piece that I think is somewhat correlated, or somewhat related to that, which is, you highlight that the majority of users are running older versions of Kubernetes, older being, several releases behind what's the main upstream. I'm curious, you obviously, Datadog doesn't necessarily sell Kubernetes, but you talk to users and so forth. Do you find they wish the releases came out less frequently, hence why they're further behind? Or just, do you think we'll have to see the industry have to adapt to make longer life cycles of Kubernetes? Like 3 months, 4 months is pretty quick to have to be constantly churning, cluster versions and so forth?
I mean, these versions of Kubernetes are coming out rapidly in part because it is a young product and they are adding a ton of features at a very high velocity, right? It really does speak well to the popularity of not just the consumption of the product, but the rate at which people are donating back to the product and how many developers are excited to work on the project. So I don't think anybody, well, I could be wrong, but it's not like I'm hearing that people wish they would throttle back or anything. But I do think that we see main part of the distribution shifting backwards in time a little bit, and might continue to do so just because this is an infrastructure component. When you're running a company and you have thousands of workloads, hundreds of thousands of workloads on a Kubernetes platform, and that's serving production customers, right? This isn't a science experiment anymore. Everybody has moved from staging, from development into production. Some people have lifted and shifted their entire infrastructure into their Kubernetes clusters so that they have a basis on which to continue iterating. If the platform goes down, that's a real problem, right? I think teams want practice with the new features, with the new levers. There's a lot of vocabulary to learn in Kubernetes, and every release adds some more of that. So I think teams just naturally feel conservative about making major updates that could have breaking changes on something that touches so much of their customer base.
Right, exactly. Like I mentioned, the work that you guys published is, entirely focused on, what's being run in the public cloud, AWS, Azure, GCP, and others. Are you surprised at, how many people run stateful workloads on top of Kubernetes when, they have database as a service, ML as a service, other sort of immediate as a service also right there? Are you surprised at how many still run things on Kubernetes as opposed to running them off cluster? Or, do you have any?
Yeah, I mean, stateless services is definitely easier to run. And like I said, Datadog runs quite a large time series database and event service, event store, all on Kubernetes, and we certainly know the difficulty there. But we also, I guess it's not surprising in part because we do it and it works so well for us. Right. It's definitely more difficult, but you have to run stateful workloads somewhere, and Kubernetes does provide a lot of affordances to make it possible to run it in Kubernetes and realize a lot of the benefits that you moved there to begin with for. Am I surprised? It's a good question.
Yeah, I mean, we are seeing, every major database, whether it's vendor or project, making their stuff available on Kubernetes, whether it's through an operator or something else. So I say like surprising. I mean, I think people want to make their stuff run in all the places people want to use it. I was a little surprised just given that, an RDS is, right there. You can click on it as opposed to, like you said, taking on this thing, which is somewhat more challenging in Kubernetes.
People definitely do use the first party products of the cloud providers. It's not like we're seeing RDS taper off or anything that is enormously powerful, but for the reasons that people were running their own databases, their own stateful services anyway, they already made that calculation, right? When they decided to invest in their own proprietary solution for something, and those calculations don't really go away just because they adopted Kubernetes for their stateless workloads.
Sure. One last question. I'm going to ask you to put a little bit of your crystal ball hat on. As you're thinking about, trends that you're watching evolve over time, what are some of the things that are, have you curious or have, kind of piquing your interest in terms of container usage, trends around the container ecosystem, whether it's a service mesh, serverless, way people are doing security? What are some of the things that kind of, you have on your radar screen, if you will?
Yeah. So one of the ones that I think is going to be in the immediate future that I touched on earlier is that people are ready for optimization, right? The reason people chose Kubernetes is not just to have an API entry point to deploy apps, but also to scale those apps up and just as importantly down. based on volatile usage. And the down part is actually important. People do want to optimize costs without sacrificing performance. And now that we've shifted into Kubernetes, into ECS, people are at the maturity stage, are ready in the immediate future to be optimizing these workloads. And I'll be paying close attention to that. We are seeing some service mesh usage, especially in development environments. People are getting a feel for that, but I do think that there's a natural alignment with Kubernetes and ECS, and I do imagine we'll see more of that. I also see serverless containers as being just enormously popular, right? If you have a container image, you've already turned your application into a Docker image. If you can give that Docker image to AWS or Azure or GCP and just say, hey, run 12 of these, run 100 of these, whatever, and not have to worry about anything, it's a very good developer experience. And I think that's bearing out both in the products that the cloud vendors are building and the consumption of those products. And I expect it to be a fairly strong pattern. Another one last thought that I have, you touched on security, and I'll layer on compliance a little bit, but people are figuring out what isolation means on shared hardware, right? Again, we're going away from each app team having their own hardware, and now we're talking about maybe namespace isolation in Kubernetes, and how to use namespace isolation and RBAC in Kubernetes, and that's definitely something I expect people to get more and more sophisticated with in the coming years. We're already seeing a lot of development in that area in our customer base, even changing in the last quarter or so. Usually an increase in sophistication there.
Interesting. Very good stuff. Michael, thank you so much for the time today, for sort of the insight. It's always good to sort of dig into the numbers, but then it's also kind of good to be able to get some context around it. So folks, with that, I'm going to wrap it up. I want to thank Michael for the time today. I want to, on behalf of Aaron and I, we're going to wrap up there. We want to thank you as always for listening to the show, for telling a friend, for helping us grow the community, and for giving us some feedback in all the places that you find your podcast. So with that, I'm going to wrap up, and we will talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.